When we look up at the night sky, we see a vast, peaceful expanse. But the physics of the early universe suggests a different reality. Space is a minefield, loaded with objects that are microscopic, invisible, and violently energetic. The smallest of these belong to Tier 1. Despite their size, they contain the mass of a small mountain, making them denser than every atomic nucleus on Earth combined. They exist now only because they are still evaporating. In 1971, Stephen Hawking proved that all black holes leak energy at their outer edge. The smaller the object, the faster it leaks. A black hole with the mass of an asteroid evaporates in seconds. Its final release of mass energy creates a gamma-ray flash, brighter than every quasar in the universe combined for a fraction of a second. The Fermi Space Telescope has monitored the sky for 15 years and detected nothing. If these primordial objects formed, they either evaporated before our solar system existed or are too rare to be found near us today. While the microkillers remain theoretical, the next tier is fully confirmed. These are heavier by a factor of 10 billion billion. Tier 2, stellar mass black holes. They form when a massive star exhausts its fuel. Without the outward pressure of fusion, the core collapses under its own weight, while the outer layers blast away as a supernova. What remains is a black hole between 3 and 100 times the mass of our Sun. We detect them when they collide or pull material off a companion star. In September 2015, two of these merged 1.3 billion light-years away. In 0.2 of a second, 3 suns of mass converted into ripples in spacetime, releasing more energy in that instant than our Sun will produce in its entire 10 billion-year life. There are roughly 100 million of these objects in the Milky Way alone. Because they are mostly invisible, we only confirm their presence when they interact with nearby matter or distort the space around them. Beyond the stellar mass tier, the universe created objects that existing models of stellar evolution cannot explain. Tier 3 comprises intermediate mass black holes, between 100 and 100,000 times the mass of our Sun. This range was once considered a forbidden zone. According to our models, stars in this mass range should explode completely upon death, rather than collapsing into a remnant. In 2019, gravitational wave detectors caught a signal that broke this rule. 2 black holes weighing 66 and 85 solar masses merged. Both parents existed within the forbidden zone, forming a remnant of 142 solar masses, the first intermediate black hole ever directly observed. Scaling up further leads to Tier 4, supermassive black holes. These inhabit the center of every large galaxy, including our own. In 2019, we photographed one of these titans 55 million light-years away, revealing a dark center and a ring of light, exactly as Einstein's equations predicted in 1916. These objects share a strange trait. Their mass tracks the mass of their host galaxy with near-perfect precision. This indicates that the black hole and the galaxy influence each other's growth, though we do not yet know which one is the primary driver. The largest directly observed objects are Tier 5, ultramassive black holes. The most massive measured to date is TON 618, which is 66 billion times the mass of our Sun. Its event horizon is 11 light days across. For scale, the Voyager mission has been flying for 50 years and has not yet traveled the distance required to cross the radius of TON 618's event horizon. TON 618 defies current physics. It is too large to have formed through normal feeding rates in the time available since the Big Bang. A stellar mass black hole should not be able to reach this size by the age of the universe we are observing. This leads to the theoretical Tier 6, stupendously large black holes. Proposed in 2021, this category describes primordial objects ranging from 100 billion to 1 quadrillion solar masses. We use the cosmic microwave background to set the upper limit for these objects. Anything heavier than a quadrillion suns would have distorted this leftover light from the Big Bang in ways our instruments would have already measured. If they exist, they could resolve the mystery of dark matter. A single Tier 6 object would anchor the gravity of an entire galaxy cluster, keeping the Milky Way and Andromeda on fixed orbital paths. This suggests the universe might be built upon a hidden infrastructure of these dead objects, providing the gravitational rails that galaxies follow. The final tier is not defined by increasing size, but by a change in how we define the boundaries of the universe itself. Calculate the event horizon radius of the universe's mass, exactly 13.7 billion light-years. A collapsing sphere and an expanding universe return the same equation. Physicists propose Tier 7. We may be inside one. This creates a boundary that an internal observer could never cross. Since general relativity cannot describe the singularity inside such an object, we lack the physics to define what exists beyond this limit. If this arithmetic is correct, our night sky isn't a window into an infinite void. It is the inescapable interior wall of a cosmic prison.